All right, you guys. So I'm sorry about the abrupt ending on that last video. I had a meeting I had to get to, and I did not realize that number 20 was going to be such a nightmare. Now look, 20C was just, like when I was getting through it, I was like, it cannot possibly be this difficult. Yeah, it's a huge pain. I'm going to show you guys how to do it. Don't worry. I really, other than like understanding the concepts, I don't think you're going to have anything that's difficult, right? Probably not even on your AP test, but check it out. In order to know where any tangent line is vertical, that's like the key of what we're talking about here, you have to set the bottom equal to 0. All right, so I'm going to go ahead and solve this right here. So 2xy minus x to the third is 0. Okay. Technically, to solve this, what I would need to do is I would need to factor out an x, set these both equal to 0. So I get x equals 0, and then I get 2y minus x squared equals 0, which when I solve that becomes 2y equals x squared. Now, there is no place on this graph where x equals 0, because if I come back up here and I try to put in x equals 0, 0 minus 0 equals 6 is not even like a thing. That's not going to work, okay? So I don't even really have to worry about that. I just have to worry about any points that fit this condition, right? So it's like, all right, here we go. 2y equals x squared. I think we got to that point. Well, I'm going to go ahead and just put this as y is 1/2 x squared, or y is x squared over 2. So any points that are going to work are going to be meeting that condition. Okay, well, now I'm going to go up to the curve. And basically what I have here is I have two equations with two variables. So I need to solve this system of equations. So it's like I'm going to take, let's say this right here where y is x squared over 2. And I'm going to plug that in there and there. Okay, so check this out. X times y squared. Well, y is x squared over 2. And then x to the third. Oh, sorry, and it was x times y squared. All right? X to the third is x squared over 2. Or x to the third y, right? Equals 6. Okay, right here, I'm actually going to go ahead and like square that first. So it'll be x times x to the fourth over 4. And then x to the third times x squared over 2. So it has to be something on that curve, right? Well, look, this is x to the fifth over 4. This is x to the fifth over 2 equals 6. Okay, I know it's not just me. We all kind of hate fractions, right? So I'm going to go ahead and multiply everything by 4 to get rid of that fraction. So I get x to the fifth. And then 2 goes into 4 2 times, minus 2x to the fifth, and then 6 times 4 is 24. So if I subtract that, negative x to the fifth is 24. So x to the fifth is negative 24. So x equals the fifth root of negative 24. Okay? And I was like, surely that can't actually be the answer, because that is super crazy. Okay? Well, if I go into my calculator, I know I have a little calculator thing on here. I guess we can just use like Desmos calculator real quick. Okay. Oh, look, my house. All right, let's see. Scientific calculator. Let's just see if Desmos scientific. Well, this is like fine too. Negative 24. Okay. To the. No, I got to use Desmos. Sorry, that calculator's bugging me. All right, here we go. Here we go. We can do the fifth root of negative 24. Okay? And it's like negative 1.888. And I'm like, can that actually be the answer? Check this out, though. So I graphed it, right? That's not the one I graphed. Let's see here. It's right here. Oh, I must have erased it. Hold on, let me get the graph back. Okay, so first of all, look at like how ridiculously crazy this graph is. Isn't that cool? This is the graph of that original curve that we started with. That's what it looks like. Now this wanted to know where is this going to have a horizontal tangent? Like, it's got to be like right around there somewhere, right? Well, check it out. I basically solved these equations of where those equal each other. So that's the condition where it's going to have, or sorry, a vertical tangent. Look where it is, negative 1.888. I was like, you cannot be serious. So sometimes you just get these really like crappy answers of like the 5th root of negative 24. Okay, so like I said, don't stress, but it's good for us to look at all different sorts of types of problems. Let's go back to look at some of the pretty normal stuff now that we get that out of the way. Yeah, also sorry, this copy is really like just like a, this review is like copies of copies of copies. I really need to take the time to retype it, but okay, here we go. Here's our next one. All right, x squared plus 4y squared is 7 plus 3xy. Show that dy dx equals this. This lends itself very nicely to like a free response type question that you maybe see on your test, okay? So if I'm trying to show that, all right, I'll go ahead and take the derivative of this implicitly. So 2x plus 8y dy dx. Derivative of 7 is 0, and then here I want to do a product rule, right? Derivative of the first times the second, and then the first derivative of the second. Now remember, what we want to do is we want to get everything with a dy dx, okay, on one side. So on this side, I'm going to have it say 8y dy dx minus 3x dy dx, and anything without a dy dx on that side. So the 3y will stay here, but minus 2x will join it. All right, now I'm going to factor out a dy dx and then divide by 8y minus 3x on both sides. Okay, so that is me showing, let me just check and make sure, yeah, that 3y minus 2x over 8y minus 3x. That's just showing the work to show that that is exactly what the derivative would be. Okay, next part. Show that there's a point with an x coordinate of 3. Okay, so that's important right there. An x coordinate of 3 where the line tangent to the curve is horizontal. Find the y coordinate of that point. Okay, so let's let x be 3 and let's plug into dy dx. So I'm going to say let x be 3. Now when I plug that into dy dx, I get 3y minus 2 times 3. And then I get 8y minus 3 times 3. Okay? So I get 3y minus 6 over 8y minus 9. And it's telling me that the line tangent is horizontal. A horizontal tangent means the top equals 0. Vertical is when the bottom equals 0, okay? But I'll have a horizontal tangent when 3y minus 6 is 0. Well, if I solve that, 3y equals 6, y equals 2. So show that there is a point where x coordinate is 3, where the line tangent of the curve is horizontal. Find the y coordinate. The y coordinate would be 2. So it's basically the point 3, 2. Now, find the value of d2y dx2 at that point. So now I need to do a second derivative, okay, from here. And I got to do a quotient rule. All right, so I'm coming back to this point. Going derivative of the top, okay, so that's 3 dy dx minus 2. Okay, that's derivative of the top times the bottom minus the top, okay, times derivative of the bottom. My goodness, I got to give myself a little bit more room here. Okay, the derivative of the bottom will be 8 dy dx minus 3 all over the bottom squared. Now, don't even think about trying to simplify this, right? There's no way. This is like absolutely horrible. What I am going to do is I'm going to say, okay, x is 3, y is 2. So wherever I see an x, I'm going to use 3. Wherever I see a y, I'm going to use 2. And then I actually need to figure out what I should plug in for dy dx, because that's the other thing. Like right here and right here, I need to use, like, plug in dy dx. Okay, so let's go up to, if this is dy dx, if y is 2 and x is 3, y is 2 and x is 3, I get 6 minus 6 over 16 minus 6. Oh, that was so dumb of me. Of course dy dx is 0, because that was the whole point, because that's where it had a horizontal tangent. Okay, Mitchell, think. All right. Here we go. 3 times 0 minus 2. So that's going to give me negative 2. And then, hold on here, what is happening? Okay. Yeah, so dy dx was 0. Okay, so 3 times 0 minus 2, so that's negative 2. 8 times 2, 3 times 3, so that's 16 minus 9, so that's 7. Okay. Y is 2, x is 3. 6 minus 6 is 0. And then it doesn't really matter what this is, but since that's 0, that's negative 3 anyways. And then, okay, y is 2, x is 3. 16 minus 9 is 7 squared. So I have negative 14 minus 0 over 49, which you can leave your answer like that, or you can reduce it by 7 and get negative 2 over 7. Oy, that was crazy. All right. What do you guys think? Are we good with that? Okay, I'm ready for some easier questions. What about you guys? All right, check it out. Consider the function where k is a non-zero constant. Okay, so k can't be 0. Oh, geez. I was like, okay, this is really hard to see. Okay, so this function actually says x to the k minus 3x squared plus 1. Okay, so k is the exponent. Okay. So first thing is saying let k equal 2. All right, part A. Let k equal 2. Now, if k equals 2, it already tells me what it's going to be, okay? Okay, so what this is showing me is, like, if k is 2, x to the 2 minus 3x to the 2 plus 1 is going to convert into negative 2x to the 2 plus 1 because I'm combining like terms, okay? Look, it already like shows me that right here. So here's my function. Okay, now it says, explain why there must be a value c between negative 1 and 2 where the derivative equals negative 2. Okay, that's definitely going to be mean value theorem. Now, my endpoints are negative 1 and 2. So remember, you want to do slope, f of b minus f of a over b minus a. Well, f of 2, if I plug in 2, here, I'll write it over here. F of 2 is negative 2 times 2 squared plus 1. That's negative 8 plus 1, that's negative 7. F of negative 1, negative 2 times negative 1 squared plus 1. So that's negative 2 plus 1, which is negative 1. So it's going to be negative 7 minus negative 1 over 2 minus negative 1, which will give me negative 6 over 3. So you would say by MVT, there exists a point in the interval, 1 to 2, such that f prime of c would be negative 2. Okay, it's just by the mean value theorem. Now it's like this next one, let k be 3, so that now I'm using this function. So now I have a new function for part B. Let k be 3, and it's telling me what it is. It's x to the third minus 3x squared plus 1. Why must there be a value r for which f of r equals 0? Okay, I'm pretty sure this has a prime And I'm pretty sure that this does not. You guys, when I see that it does not have a prime, that's actually not mean value theorem, that's intermediate value theorem. Okay, intermediate value means it's between two values. It doesn't have anything to do with the derivative or the slope, all right? So check it out. Let's find f of 2, because that's my first one, okay? Just f of 2. 2 to the third, 3 times 2 squared plus 1. So it's going to be 8 minus 12 plus 1, which is negative 3. Okay? And then let's find f of 4. Well, that's going to be 4 to the third minus 3 times 4 squared plus 1. So that's going to be 64 minus 16 times 3 is 48 plus 1. 16. So I think that's 17. And so then what you say is by IVT, intermediate value theorem, there has to be a point where f of r equals 0, because 0 is between negative 3 and 17 on the interval from 2 to 4. So intermediate value theorem just means if I have a bunch of numbers, it has to cross through every number in between. Mean value theorem means slope equals derivative. All right? Last part. Let k equal 4 so that f of x is x to the fourth minus 3x squared plus 1. So that whole let k equal, it's just because we're using a different equation every time. So don't get all hung up on that, okay? Equation of the tangent line. So what do I tell you guys? Whenever we see those words, we're going to write y minus y1, mx minus x1, and fill it in. The point whose x coordinate is 2. So how do we find the y coordinate? Well, we find the y coordinate by just plugging it in. So 2 to the fourth minus 3 times 2 squared plus 1. Okay, that's going to give me 16 minus 12 plus 1, which is 5. Okay? Move that over a bit. All right, so y minus 5. And then I have to find m. And how do I find m? Well, I find that by plugging into the derivative. So the derivative is 4x to the third minus 6x. Now, when I plug that in at 2, I get 4 times 2 to the third minus 6 times 2. So 8 times 4, that's 32 minus 6 times 2 is 12. So that's 20. Boom, equation of my tangent line. All right. Whew, my goodness, we're only on number 23. Yikes. All right. Oh, but we're going to hit a bunch of L'Hopital's questions and stuff. That's going to start going really quick. Okay, here we go. We're getting past some of these long ones. All right, let f and g be differentiable functions, and the value of f, g, and the derivatives are all in the table below. Determine the value of each of the following. Oh, this is the best. You guys ready? These are so great. Look. If I'm adding two functions, the derivative would just be f prime at 2 plus g prime at 2. When you're adding, you just add the derivatives, right? Well, f prime at 2 is 6. G prime of 2 is 7. 6 plus 7 is 13. Okay, now for here, I'm going to have to do a product rule because I'm multiplying. So I'm going to have to go derivative of the first times the second plus the first times derivative of the second. Getting all of this from my chart. Let's see, f prime of 2 will be 6. G of 2 will be pi. Plus f of 2 will be 2. And g prime of 2 will be 7. Okay, so that'll basically just be 6 pi plus 14. Weird. But okay. F divided by g, well, that's going to be a quotient rule. Derivative of the top times bottom, top derivative of the bottom over bottom squared. Okay, this is all at 2 again. F prime times g, so that'll be 6 pi, minus f times g prime, 2 times 7, over regular g squared. So this one will be 6 pi minus 14 over pi squared. All right, and then last but not least, our fantastic chain rule. Now you guys remember when we're doing chain rule, we're going to do derivative of the outside, leave the inside the same, times derivative of the inside. Okay, so I'm doing f prime of g of 1 times g prime of 1. So I'm going to start here, okay? G of 1 is 2. G prime of 1 is 4. And then now I'm going to do this. So f prime of 2 is 6. So it'll be 6 times 4, which is 24. All right? Okay. You know, a lot of these are actually not L'Hopital's rule. What these are, when you guys see, okay, when you see this, f of x plus h minus f of x over h, I want you to immediately think, oh yeah, that means derivative. If it follows that, okay? If it follows this, limit as x approaches a, f of x minus f of a over x minus a. So again, I'm bringing 2 points really, really close together. That also means derivative. These are very, very like easy AP questions if you remember that. Okay, so what this is saying, here's how I'm going to interpret this when I see it. Here's what this is saying. Find the derivative of that, which is sine x, at that, pi over 2. Now that's not what it says. It's a limit problem, but it's not really a limit problem. It's a derivative problem. It's just using the definition of the derivative. So find the derivative of sine at pi over 2. That's your task, right? Well, the derivative of sine is cosine, and at pi over 2, pull out your best friend chart, cosine pi over 2 is 0. So that equals 0. Okay? It's not really a limits question, it's a derivative question. All right? These show up on the AP test. They used to always confuse the heck out of me. Okay, check it out. The limit, blah, 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 is. It's not really asking me for a limit. It's asking me for a derivative. So what is it saying? It's saying find the derivative of 3x to the 37th. And on this one, I'm not even plugging in a number. Okay? What's the derivative of 3x to the 37th? Oh, now, it's not even making me find it, I guess, because what's 3 times 37? But it's basically saying this is the definition of the derivative at 3x to the 37th, right? So it just wants you to know if you, it wants to see if you recognize what the equation is that's like inside of that. Okay? Okay. Okay, here we go. This is another like derivative, like definition question, because this is saying as x approaches 0, so it's like f of x, g of x minus g of 0 over x minus 0. This means, again, I'm going to interpret it, okay? Find the derivative of g of x evaluated at 0. Okay? Because it says x is approaching a. Whatever that number is, that's what I'm going to evaluate it at. So what, and if it equals 1, what does that mean? Well, it means the derivative at 0 is 1. See how these aren't like hard questions? It just wants to make sure that you understand what all this like crazy notation means, okay? Okay, now, what you're going to more see on your test, though, is L'Hopital. And 27, 29, 30, 31... These are all L'Hopital, okay? So let's go ahead and we'll go up to like 31 so we can finish off with some L'Hopital, all All right. Okay, right now, if I plug in 0, remember, you always want to plug in 0 first just to make sure. E to the 0 is 1. E to the negative 0 is 1. The cosine of 0 is 1. So 2 times 1 minus 4. And then over 0 squared. So look, 1 plus 1 plus 2 is 4 minus 4. So I get 0 over 0. Which means I can use L'Hopital. I really hope I only have to do it once. But we shall see. Now L'Hopital states I'm going to go ahead and I'm going to start on the top and I'm going to take the derivative of all of that, okay? Do that again. There we go. All right. Derivative of e to the x is e to the x. The derivative of e to the negative x is e to the negative x times a negative 1. So I'm going to go ahead and put like the negative 1 right there if that's okay. So instead I just made it negative, but that's my chain rule, all right? The derivative of cosine is negative sine, so I'm going to do the same thing, and I'm going to put my negative right there, and then that goes away. Derivative of x squared is 2x. Now, is it still 0 over 0? I don't know. Let's see. Boom, boom, boom. Okay, e to the 0 is 1. E to the 0 is 1. Sine of 0 is 0. And then 2 times 0 is 0. So I get 1 minus 1, that's 0 over 0. Rats! I'm going to have to do it one more time. But that's okay, because I can tell after this one I'll be chilling. Because at least the bottom will be fine, right? All right, here we go. E to the x is e to the x. E to the negative x is e to the negative x times the negative 1. But again, instead of writing it over here, I'll just put plus. Derivative of sine is cosine, and then on the bottom, the derivative of 2x is 2. I am feeling so good about this. Here we go. Okay, e to the 0 is 1. E to the 0 is 1. Cosine of 0 is 1. I don't love that, but that's okay. So that's 2 minus 2, which is 0 over 2. Which isn't as satisfying as I wanted it to be, but it's fine. It's 0. All right, it's 0 by L'Hopital's. I was hoping it would be something more cool. All righty, let's look at this. Is this? Oh, it actually is a L'Hopital question, I think. Well, we want to know if it's continuous or not. We'll also talk about if it's differentiable or not, okay? But first, let's see if it is continuous. How can we tell? Well, I would plug in 0 here. And you guys, when I plug in 0, I get, okay, cosine of 0 minus cosine of 0 over 0 squared. Well, that's 1 minus 1, which is 0 over 0, which means I can use L'Hopital. All right? Because basically, I'm trying to find the limit as x gets really close to 0. So I'm going to do L'Hopital. Okay, derivative of cosine is negative sine 3x times 3. The derivative of cosine is negative sine 4x times 4. So negative turned into a positive. The derivative of x squared is 2x. Whew. Unfortunately, I'm going to have to do this one again. I can already tell because it's 0 plus 0 over 0. So that's fine. Let's do it one more time. Okay, negative 3. The derivative of sine is cosine 3x times another 3. You can turn that into a 9 or not. Look, I'll just leave it separate. It's fine. The derivative sine is cosine of 4x times another 4 over 2. Now when I plug in 0, you guys, and if I remember that the cosine of 0 is 1, I am going to get, okay, negative 3 times 1 times 3. I'm going to get 4 times 1 times 4. So I'm going to get 7 over 2. So I did L'Hopital's a couple times. So this limit is getting really close to 7 over 2. That's getting really close to 7 over 2. So this is most definitely continuous. All right, it's definitely continuous. Now, in terms of if it's differentiable, I'm not actually going to do that on this problem. They wouldn't really ask you that. But basically, it's asking if the derivative of that and the derivative of that would be the same thing, if it would be differentiable right there. All right. I would imagine if you did have a question like that, you'd at least have a calculator. So let me show you what that looks like. All right, this is pretty cool. Okay, this is the graph of cosine 3x minus cosine 4x over x squared. And what it's saying is it continuous right here? Okay. So it's asking if the limit equals the point. All right. Actually, you know what? The limits are equal to each other, but because it's actually undefined right here, because that's undefined, you can kind of see my undefined point. Hang on, let me get it right there. At 0, it's actually undefined. So is it continuous? Maybe it's not continuous right here. Don't I have a little point right there? It's hard to see it, but it goes away. It's undefined, actually. So it's not continuous, but actually it does look differentiable. So I'm actually going to switch that up. Okay? It is not continuous, but it is wait. No, in order to be differentiable, it has to be continuous. So it's also not differentiable. That's confusing. That's confusing. Yeah, it actually has a hole. It's going to come up like that and have a hole. Okay? So it's not going to be continuous or differentiable right there. Oof, what a question. The questions that look like this, you guys are off of AP Classroom and they are tricky. Okay. Let's take a look at this one. This is a lot more the speed of type of questions we're going to see on the test. Okay, honestly. Okay, check it out. If I plug in 1, remember, ln of 1 is 0, and 1 minus 1 is 0. So I know this is a L'Hopital. Okay? So the limit as x approaches 1. Now, if I do derivative of the top, that will be 5 times 1 over x. And if I do derivative of the bottom, the derivative of x is 1. So when I go to plug it in, it's 5 times 1 over 1 over 1. Okay, that's a lot more the speed of what we're going to see on our test, all right? This review is a little nutso. But if you're understanding everything, a really, really good review of some like higher end questions. Okay, check it out. If I start by plugging in 0, 3 times 0 is 0. The ln of 1 is 0, so it's 0 over 0. So let's go ahead and do a L'Hopital on this. Derivative of 3x is 3. The derivative of ln of 1, the ln of x plus 1 is 1 over x plus 1 times 1, because the derivative of the inside, okay? Now, I'm just going to go ahead and leave it like this. I'm not even going to simplify it, you guys, because look, when I plug in 0, I get 3 and then 1 over 1, which is just 3. Okay? And let's go ahead and do one more. Let's go ahead and do number 39 or 31, just so that this section will end with another L'Hopital. All right, if I try to plug in 0, now the fact that it says from the right, you know, that doesn't really matter unless there's an asymptote. I'm still going to do L'Hopital. E to the 0 plus e to the 0 is 1 plus 1 over 0. So this is 2 over 0. Okay, this is actually not a L'Hopital question. And that's basically what we want you to see on here, is that not everything is L'Hopital, right? I'm not going to go ahead and try to do, you know, the derivative of the numerator, the derivative of the denominator, try to figure it out, because it's 2 over 0, which is undefined. So most likely you would have like a choice or whatever that says the derivative does not exist. Okay? Now, again, if we had a graphing calculator, we could do the graph of this, right? I do not expect that you guys would be able to graph this without a calculator. But if this were on a calculator section, all right, let's take a look at what this would look like. You guys, dang, this is one of the coolest things I've ever seen. Now, let me show you the graph of this. But remember, when I'm dividing by 0, it's undefined. The derivative does not exist. Let me show you why. Look at this graph. It's so crazy. I wonder how much more. Oh, it just keeps going. It just keeps giving me more and more little like bumpy things as I go on. That's insane. I love it. Anyways, let's go back to normal. Boop. Okay, so you kind of can just see it barely from the beginning. But what's happening as I'm approaching 0 from the right? Well, yeah, the limit does not exist because that keeps going up to positive infinity. On the left, it's going down to negative infinity. So, you know, I suppose you could also say, well, this is approaching positive infinity. That could be an answer, or it does not exist. Look, it's never going to give you both and make you choose from those. So it'll have one or the other. Okay? Sweet. Let's call it good for this section, guys.